All right, students. So addition and subtraction in scientific notation, and it's actually harder than multiplication and division, but it can be done. So let's say we have a number. Let's say we have two numbers. So 3.27 times 10 to the power of 6, and then I'm going to add that to 4.67 times 10 to the power of 7. Okay. Well, actually, let me make it a little easier. So 4.67 times 10 to the power of 6. Right? If I expanded these out, I would take the decimal and I would move it 6 spots. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I would add that to 4.67 and move that 6 spots. 1, 2, 3, 4, 5, 6. So, and then I can add them together. So the zeros all add. The 7 and the 7 is 14. The 6, 2, and 1 is 9. And 4 and 3 is 7. So I have 7940000. And if I move the decimal back here, 7.94 times 10 to the 1, 2, 3, 4, 5, 6th power. Okay. So they're the same number, because if we remember from our decimal making scientific notation, this is basically the place value. So we're moving the decimal 6 places to make it an easier multiplication problem. So basically I've got 3.27 plus 4.67 times 10 to the power of 6 times 10 to the power of 6. Right? So these are the same, so it's the same place value. So now I can just add straight down. 7 and 7 is 14, 6 and 2 and 1 is 9, 3 and 4 is 7, so that's times 10 to the power of 6. Right? Another way you can think of it is the distributive property. So I have a multiplication plus a multiplication problem. And so I can factor out the 10 to the negative 6 problem. So this is 3.27 plus 4.67 times 10 to the power of 6. Mm-hmm. And then I add these together and I get my 7.94 times 10 to the power of 6. And that's pretty easy. So when I'm adding or subtracting stuff together, if the scientific notation is the same, then it's really easy to add. When it gets difficult is when they're different. And it's really not that much difficult. So if I have 2.54 times 10 to the power of 6, and I want to add 4.67 times 10 to the power of 7, you can see the exponent 6 and the exponent 7, they're different. So if I expanded these out, so if I move this 6 spots, 1, 2, 3, 4, 5, 6, so that would be this number. And if I expanded this one out, 4.67, 1, 2, 3, 4, 5, 6, 7. Now I've got these two numbers. So let me rewrite them so they're a little neater. 2540000 and 4670000. Right? So now if I'm adding them together, you'll notice the 4.67 and the 2.54, the decimals aren't lining up again. When I expand them out, the original decimal was here and here. So I can't just add them straight down. I have to, if I expand them, I can add straight down. But with this, now I've got to change this. So I've got to change one of these exponents. So if I change this exponent to a 7, that means I'm multiplying 2.54 times 10 to the power of 7. So I'm multiplying by one more 7. So to get this 2,540,000, I've got to move my decimal point over one spot. Right? 0.254 times 10 to the 7, 0.254 times 10 to the 7 means I'm going to move this 7 spots. And so I get this 254 million, right? 254, 1, 2, 3, 4. 254, 1, 2, 3, 4. So these are the same number. But now I can add it to 4.67 times 10 to the power of 7 the same way I did before. So I can add 0.254 times 10 to the 7th, and then 4.670 times 10 to the 7th, and that's times 10 to the 7th over here. 4 plus 0 is 4, 5 plus 7 is 12, 6, 2 plus 1 is 9, 4 plus 0 is 4, so I have 4924 times 10 to the 7th. And it works that distributive property too. 0.254 times 10 to the power of 7 plus 4.67 times 10 to the power of 7. I can factor out 10 to the power of 7. So I have 0.254 plus 4.67 times 10 to the power of 7. So I add these together, and I get the 4.924 times 10 to the power of 7. So that's adding, and then subtracting is the exact same way. So if I have two numbers and I want to subtract them, then I can do this, the exact same thing. So let's say I have 6.9 times 10 to the power of 4 minus 3.8 times 10 to the power of 3. So I've got to move one of these decimals, so I'm going to move this one. I want to make it smaller, so I'm going to move it this way. So instead of 6.9, I'll have 69 times 10 to the power of 3 minus 3.8 times 10 to the power of 3. So now I can do 69 minus 3.8. So I have to put my 0.0 in there. So now I can simply subtract. 10 minus 8 is 2. 8 minus 3 is 5. 65.2 times 10 to the power of 3. I need to put this back into scientific notation, so the decimal has to be there. 6.52 times 10 to the power of 4.